Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode we're going to be talking about the basic proportionality theorem or the Thales theorem. So in the previous episodes we talked about the similarity criteria, how triangles can be classified basing on sides and angles. So if you haven't checked it out, I recommend checking out that episode because there is some information that will be used from those episodes in this episode as well. So without any further ado, let's actually talk about the basic proportionality theorem. So basic proportionality theorem was first introduced by Thales. He was a famous Greek mathematician who lived from 640 BC to 546 BC. And one of the theorem is what we'll be talking about today. So without any further ado, let's talk about it. So the first theorem says that if a line is drawn parallel to one side of a triangle, then the line and if the line passes through two different sides, which are two distinct points, then the triangle is divided into two parts which are in same ratio. So for example, let us take this as a triangle. Now, like I said, if a line is drawn, so let me draw a line which is parallel to one side of the triangle. So this is parallel to one side of the triangle, passing to two sides. So it is passing through two sides with distinct points. So let's call them P and let's call this Q. Then the triangle will be divided into equal ratios. So this means that this ratio will be equal to this ratio and this will be equal to this. So basically what it's saying is AP by PB is equals to AQ by QC. So this is the first theorem that Theorem suggested. So now let's talk about the second theorem. Now this is really important theorem because this will be used commonly. We can also prove this theorem. So yeah, now let's talk about the second theorem. So let's put this away. So the second theorem. So the next theory suggests that two triangles which have the same base or equal bases have the same area when they are in between two parallel lines, or whether they are between two parallels. So for example, let us take two parallel lines. Let's say both of these are parallel. And let's draw a triangle. Using the same base. So if a triangle is drawn, let me draw this. Let's see. So if a triangle is drawn like this, so that means it basically follows theorem. So basically what it's saying, if two triangles are on a single base with two parallel lines, that means that the area of these triangles will be equal. So for example, let's call this A, B, C and D, right? So let's call these points this. So that means that area of, let's see, A, B, C will be equal to the area of ABD. So that is what the second theorem suggests. So now that we talked about this, let's talk about the area of a triangle. So how do you find out the area of a triangle? The answer is simple. This is something that that is learned in previous classes, but basically the area of a triangle is half into base into height. So this is base and this is height. So this is half into base and height, and this is the area of a triangle. So basically if this was a triangle, then half is half, this is base and height is mostly this. So this is the height. So that is a formula for a normal triangle. Now for an obtuse triangle it is different. So like we talked in our previous episode, obtuse triangle is a triangle where one of the angle is above 90 degrees and below 180 degrees. So let me draw a triangle that way. So, okay, let me draw it a lot more better. So let's say this is an obtuse triangle. Now, again, if we use the same formula, which it is the same formula for an obtuse triangle as well. So for an obtuse triangle, for finding out the area, you need to use the same formula. But when you use this formula over here, basically what happens is you find a problem. The thing is, there is no way to do to draw a height. So you kind of get confused on how to draw the height because the base is there, but what about the height? So let's call them A, B, C. So now that we draw an ABC now. Okay, so I guess there was a problem with the camera again. I don't understand this happening. I am trying to solve it. It will take a couple of episodes for this to get solved. But basically I was talking about the how to find the area of an obtuse angle. Where basically what you need to do is you can take C as a vertex and you can draw a line. We'll mostly talk about this in the next episodes, or if it's used in next episode, then we'll talk about it. But for now, this isn't that important. If we're doing more sums, we'll kind of get into it. But yeah, that is kind of the first theorem and second theorem. So in the next episode, we'll try to understand why this formula makes sense. So for example, why does this theorem exist, and how do we prove that this theorem is real? And that is the main goal of our next episode. So yeah, hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, and see you in the next one. Bye bye.